Good evening, everyone. Today we are going to present on recommendation engine for career transition. Moving on to the next slide. We have prepared this project under the guidance of Mr. Sharat, who is the director, and Aniket, who is our mentor. And we sincerely thank 360TMG for providing us this opportunity. Moving on to the next slide. There is a saying, alone we can do little, but together we can do so much. So myself, Arun Kumar, Mohammad Ziauddin, Arish Naqvi, Vijay Gauri, Mohan Kumar Subramanian, Naveen Kumar Chandramohan, Pavani Sen. Moving on to the next slide. Preeti Kandari, Prem Kishore, Anand Shweta, and Akshay Chandale have together worked as one team on this project. Moving on to the next slide. The below are the contents of the project. Recommendation engine definition, project overview and scope, project goals, CRIS ML methodology, technical stacks, system requirements, project architecture, data collection, data understanding, data pre-processing, EDA, model building, model deployment, deployment output, challenges, and future scope. Moving on to the next slide. Recommendation engine. What is this recommendation engine all about? A recommendation engine is a type of data filtering tool using machine learning algorithms to recommend the most relevant items to a particular user or a customer. It operates on the principle of finding patterns in a consumer behavior data, which can be collected implicitly or explicitly. It is also known as recommender system, and it's a software that analyzes available data to make suggestions for something. Moving on to the next slide. Project overview and scope. This project basically involves using machine learning algorithms to solve the problem of information found in any areas and allowing the users to focus only on the important information based on the area of interest. Such systems can play a major role in helping students to achieve their career goals by generating personalized job and skill recommendations. Moving on to the next slide. So this slide basically has project objectives and project constraints. To work on the requirements of recommender systems for educational guidance, these are the objectives. To build a career recommendation system for graduate students and recommend them the career path for higher studies or jobs. To design and develop a new recommender system with running time better than the others mentioned in the literature. The below are the constraints, data imbalance, not enough data points to cover all the fields, and inaccurate recommendation. Moving on to the next slide. CRISP ML methodology. So this CRISP DM basically consists of 6 phases. The first phase is business and data understanding. Business understanding. What does the business need? We have to determine the business objectives, access the situation, determine data mining goals, and produce project plans. Next is the data understanding phase. Data understanding. What data do we have? What data do we need? Is it clean? So we need to collect the initial data, describe the data, explore data, and verify the data quality. The second phase is data preparation. How do we organize the data for modeling? This phase is often referred as data munging. It prepares the final data sets for modeling. So you have to basically select the data, clean the data, construct the data, integrate and format the data. The third phase is model building. What model techniques should we apply? Here we likely build and access various models based on several different modeling techniques. Select modeling techniques, generate test design, build a model, and we access the model. The next fourth phase is model testing and evaluation. Which model best meets the business objectives? The evaluation phase looks more broadly at which model best meets the business and what to do next. It includes evaluation of results, reviews the process, and determines whether to proceed to deployment, iterate further, or initiate new projects. The fifth phase is deployment. How do stakeholders access the results? A model is not particularly useful unless the customer can access its result. So it's very necessary to plan the deployment. The last and the sixth phase is plan, monitoring, and maintenance. In this, you have to produce the final report and review the project. So if all these 6 steps fail, then you again need to start from step 1 and the whole cycle continues. So now I hand over to Arun to explain the technical stacks and system requirements.
Thank you, Vinita. Hello, everyone. I am Arun. Let me start by explaining the technical stacks. We have used Python language, which is used for data cleaning, EDA, model building, and visualization. We have used Spider and Jupyter as IDEs. We have first installed Spider. Spider is a IDE for scientific programming in the Python language. We have also installed Jupyter Notebook. Jupyter is a web-based interactive computing platform. Moving on to the next slide. The libraries used are NumPy, Pandas, and Matplotlib. NumPy is used for numerical calculation, Pandas is used for data manipulation, Matplotlib is used for visualization. For deployment, we have considered Streamlit and GitHub. Streamlit is used for creating and sharing web app for data science and machine learning project. GitHub allows user to work together on project from anywhere. Moving on to the next slide. Now we have system requirements. Memory required is 8 GB RAM and above, CPU Intel Core i3 and above, OS Windows 10 and above. Preparing the environment. Install Python version 3.8. Install Anaconda software to launch IDE platform like Spider and Jupyter. Creating a new environment. Pandas is installed for pre-processing of data. NumPy for mathematical calculation. Matplotlib for visualization. And Streamlit for deployment. So now I hand over to Vijaya to explain the project architecture.
Thank you, Arun. Now we look into project architecture. Here you see different stages used to build a best model, such as data collection, creating data set, data pre-processing, EDA, model building, model deployment, and hosting. Data collection. It is a process of gathering information about the targeted variables. Here we used primary source of data collection, which is conducted surveys by creating Google Forms with required features. Creating data set. We collected data and we maintained it in the form of Excel sheet. And we did basic cleaning like removing special characters, deleting unrelated data, and check the data types. Next, data pre-processing. The main goal of data pre-processing is to get accurate data. So we did the required cleaning on the collected data like rebuild missing values, removing duplicates, and doing standardize and normalization, import and export, and then merge data by validation and verification. EDA. Here we visualize the data distribution with univariate and bivariate plots and check the correlation between variables and did imputation on missing values. And we handling the outliers and creating new features from the existing features. Model building. Here we use content-based recommended system with the data that users provided based on the data a user profile is generated, which is then used to make suggestions to the user. For model deployment. For model deployment, we use Streamlit framework for deployment. Streamlit is an open source app framework in Python language. It helps us to create web apps for data science. and machine learning in a short time. It is easy to learn and apply on with no front-end web development experience required. My teammate Arun will continue with the next slide. Thank you.
Thank you, Vijaya. This is Vinita. I'll be taking the data collection, data understanding, and data pre-processing part. Data collection. So data was collected, measured, and analyzed accurately. For example, if you see the table, the data was split into academic and professional data and personal data. Under academic and professional data, we collected undergraduate course, undergraduate specialization, CGPA, certification courses, job title, and master's course. And under personal details, we collected details like name, gender, interests, and skills. Moving on to the next slide. Data understanding. Here we have the data dictionary. This basically shows the variables that we collected and the respective data types for the variables collected. We have described these as headers, which include name, gender, UG courses, UG specialization interest, skills, CGPA, certification course details, working or not, job title, and master's degrees. In the second column, we have described whether each of these headers are in which category, nominal or categorical. And in the description column, we have described what each header means. For example, name is the name of the responder. Sex is whether the responder is a male or a female, so on and so forth. Moving on to the next slide. Data pre-processing. This involves data integration, data transformation, data reduction, and data cleaning. Data integration. This is a process of bringing data from disparate sources together to provide users with a unified view. The raw data file contained a lot of data, so we focused on the column "Are you working?", which was filled by the students. It had two options, yes and no, and we split this data into two separate files as described below. Job data file, the students who had marked yes, only those data rows were considered and worked upon to give job recommendation. Master data file, the students who had marked no, only those data rows were considered and worked upon to give master recommendation. Data transformation, it's a process of converting data from one format to another format. Here, for example, in the percentage column, we got values in the form of integer as well as float data type. So we transformed all the values to float data type. Transformations typically involve converting a raw data source into a cleansed, validated, and ready to use format. Data reduction. In the data set, we removed the unwanted rows which had no relevance. And finally, data cleaning. The data was clean and then properly structured. In our data set, there were null values which were cleaned by doing manual imputation. We also checked if there were duplicate values and we completed the data pre-processing. Thank you, everyone. That's all from me. Now, my teammate Zia will continue from the next slide. Thank you.
Thank you, Vinita, for addressing. Hello, everyone. Myself, Zia. So let me start off by explaining the definition of EDA. So EDA, or exploratory data analysis, is basically done to visualize and summarize the collected data, thereby allowing us to make tentative assumptions and pull out meaningful insights from the data collected. Coming to the first slide under EDA, as you can see, we have a scatter plot depicting the graduation scores of the population. Initially, we received the scores in CGPA as well as percentage formats. In order to have uniformity, we converted the CGPA ones to percentage by using the X 9.5 rule. Now, as you can see, majority of the population is above 60% mark, so that shouldn't stand as a barrier for the students in applying for jobs or higher studies. Next up, we have the heat map for job and master's data set. So towards the extreme left, you can see the raw data set, which has the null and missing values. Towards the right side, you can see the job and the master's data set with the null values removed or replaced and the variables that we considered for these two data sets. Next up, we have the correlation heat map. A correlation heat map is a heat map that shows a 2D correlation matrix between the two discrete dimensions using colored cells to represent data from a usually monochromatic scale. The values of the first dimension appear as the rows of the table, while of the second dimension as a column. The color of the cell is proportional to the number of measurements that match the dimension value. For example, in this figure, you can see graduation is more correlated with technical and business skills as compared to administrative skills. Next up, we have a bar graph depicting the various UG courses opted by the population. As you can see, BTech topped the chart in both the data sets. It can also be observed that people who did BTech in their graduation are more likely to opt for masters as compared to other streams. So this was one of the insights that we were able to pull out from this slide. Next up, we have a bar graph depicting the PG courses opted by the population. As you can see, MBA topped the chart, which is interesting considering the fact that majority of the population was from technical background. So people from technical background also wanted to explore the business field, maybe for an all-round development. Next up, we have a chart depicting the top fields of interest opted by the population. As you can see towards the left, we have a job data set, and the skills in the job data set are more catered towards the respective graduation streams, whereas the interest opted by the master's population are more of generalized ones. Next up, we have the model building part. So as you can see on the screen, there's a flow chart of the model. So majorly recommendation systems are built on two techniques. One is collaborative based filtering. Second one is content based filtering. Okay, let me explain you collaborative filtering system. Collaborative does not need the features of the items to be given. Here, every user and item is described by a feature vector. Whereas coming to content-based filtering system, content-based recommender systems tries to guess the features or behavior of a user given the item's features he or she reacts positively to. Content-based filtering does not require other users' data during recommendation to any particular user. So here we have followed the content-based filtering approach as we need to recommend jobs or higher studies after matching his or her inputs for each variable with a pre-existing set of inputs in the data set. So coming to the flow chart, as you can see, towards the top end, we have the data set, which is the raw data on which data cleaning is performed to remove or replace the null values. Then TF-IDF technique is applied on the word corpus, which is basically prepared from the dataset itself. Now, let me shine some light on the TF-IDF technique. TF-IDF stands for term frequency inverse document frequency. TF-IDF value measures based on the number of times a word appears in the document, and it is often offset by the total number of words in the corpus. Term frequency is given by the number of times a word appears divided by the total number of words in the file. Moving on to inverse document frequency. Inverse document frequency gives the measure like how much information a word provides. Lastly, TF-IDF converts raw strings into vectors. So now towards the bottom, as you can see, we are taking the user input and we will store the input to a data frame and then apply the TF-IDF technique by creating a word corpus. Now we will map the two TF-IDF matrix values to find the cosine similarity between the two, and the top 10 values will be presented to the user in the form of recommendation. Next up, we have the code for the model building. Okay, starting with the basics, we imported the necessary libraries, then importing and defining the data set. Then we collected the required columns, that is job, graduation, graduation stream, percentage, applicant ID, technical and business skills, administrative skills, finally interest. Then we took these columns and created a new data frame. After that, we took all the columns which have textual data and stored them together in a new column as text with the spaces between the values. Next up, we have, now we imported the TF-IDF vectorizer function from the library. Then we applied the TF-IDF technique on this text column, which serves as a word corpus for our model. Then we took the applicant ID, job roles, percentage, and the newly created text column, and then created a new data frame with these columns. Next, we defined a function to get the recommendations. Top will be the list in which the recommendation will be stored, and the recommendation which we require is from the job roles. Hence, job role columns is selected. The list will increment for each value added up to 10 values. Then we took the user input for the following variables and stored in a data frame as D. Next up, we have, now we imported the cosine similarity function. Then we applied the TF-IDF technique on the user input work corpus. Then we mapped the user input TF-IDF values to the original dataset TF-IDF values and found the cosine similarity between them and stored these values as output 2. Then we initialized the top variable to the output, and we sorted the output in descending order, that is top to bottom based on the cosine similarity score. Then finally, get recommendations will print the output, that is the top 10 recommendations to the user. Next up, we have the master's recommendation engine, which is built on the same approach as the job recommendation engine, which I just explained. Okay, next up, we have the deployment part, which will be explained by Arish.
Thank you, Zia. Hello, everyone. I'm Arish. Let me explain to you the model deployment. So once our model was prepared, we used Python and Streamlit for building the application. Streamlit library was used to build the structure of the web app to take inputs manually from the user. So the process involved pickling the model, which in our case was the dataset, vectors, and the recommendation models. Then all the files, that is the pickle files involving front-end files, output files, requirements, etc., were pushed into a GitHub repository, which was then linked with Streamlit to run the web app. Next slide, please. Here is a screenshot of our web app. Next slide, please. So let us show you the output video of our web app. So as you can see, this is the web app. So this basically involves all the inputs that have to be taken from the user end. So if you enter, you will see that you need to to choose your path, which in this case is job or masters, based on which the selected inputs will occur. So if we suppose select job over here as an example and choose, let's just say BTech, and then you can enter your graduation stream, let's say computer science engineering over here. And you can enter your graduation percentage. Also, this web app allows the user to take in multiple technical business skills and administrative skills. So let's just say we choose Python, Java, SQL, big data, C++, 2D and 3D animation, and data analysis. Similarly, you can choose multiple inputs for administrative skills. Let's say logical skills, analytical thinking. Also go with observational skills. Last, you can select your interest over here. Let's say cloud computing, data science, information technology. We can add few more. Let's just say we add software over here. Now, once you click on get job recommendation, you'll see the top 10 job recommendations based on all the user inputs over here. Similarly, if you choose masters instead of job, you'll get a different set of inputs from the user. Moving on to the next slide. So let's just talk about few challenges that we faced while doing this project. So the primary data had a lot of null values, input errors, etc. So a lot of time went in manually cleaning the mistakes. Also, data was entered in different cases, so it took a lot of time to make the data uniform. Also, units for graduation marks were not similar. For example, some people entered as CGPA and some as percentage. So we had to make that also uniform. Also, few master's recommendations have an exclusive process. For example, in order to do MTech, you also have to complete a master's degree first. So that is a pretty exclusive process, which our model couldn't involve as of now. Also, model is giving recommendation based on data from people who have switched fields. What I mean to say is that they have studied something else for the graduation and later on switched the field. So the data that we collected is not reliable in such unique cases. Next slide, please. If I talk about future scopes, so a lot can be involved in this model. So it can be made more diverse and robust by integrating data pertaining maximum educational fields possible. Also, more and more features and skill sets can be collected relevant to each educational field. Also, a model like this can be automated by only providing the updated data set, and workflow could be triggered by any method such as GitHub Actions. With respect to job recommendation, we can also add in features wherein the user is directed to the websites of the jobs vacancies that were recommended. Same goes for the master data sets. The user can be directed to links containing the courses of the said recommendations. Next slide, please. So that is the end of our presentation. That's all from our end. Thank you guys. Thank you so much for watching this. And we thank you for your time and consideration.
So if we don't have any questions from the audience, then I think we can end this presentation.